Welcome to EDU World Space.
All right, we've been given this logarithmic function, log base 2 of 2x plus 2 minus 3. And we've been asked a series of questions about it. So the first thing we want, the domain. What we know here is that for log functions, the argument, the value on the inside of the parentheses, has to be a positive number. It can't even be 0. So we know that 2x plus 2 needs to end up greater than 0. So when we subtract 2 from both sides and divide by 2, we see that the domain here has to be greater than -1. So we would write -1 to infinity. Then we're asked to calculate g of 7. So let's plug in a 7. We have log base 2 of 14, 15, 16 minus 3. Using the change of base formula, we can do log 16 over log 2 minus 3. You could also calculate that individually. Log base 2 of 16 is 2, 4, 8, 16. So 4 minus 3 is 1. So we have that. And then we're asked to solve this equation. So what would we do if we had 2 equals log base 2 of 2x plus 2 minus 3? Well, the first thing I'd do is I'd move that 3 to the other side by adding. So now we're at 5 equals log base 2 of 2x plus 2. And then to get rid of this log base 2, we're going to use both sides as an exponent on 2. So 2 to the 5th, 2, 4, 8, 16, 32. So we get 32 equals 2x plus 2. We'll subtract 2 from each side. We get 30 equals 2x, and x is equal to 15. And we know that 15 is in our domain, so we don't need to check it. And then finally, the 0 of g of x. Well, that's when we set the function equal to 0. So 0 equals log base 2 of 2x plus 2 minus 3. When we subtract or add 3 from both sides, now we're looking at 3 log base 2 of 2x plus 2. If we use both sides as a power of 2, 2 cubed would be 8, and then the log cancels. 2x plus 2, let's subtract 2, and then divide by 2, we get x is equal to 3. So 3 is a 0 of the function. So what this means is up here, this means that the point 15, 2 is on the graph. And down here, this means that the point 3, 0 is on the graph.